All right, back again. We're going to hopefully finish, or maybe one more video after this, starting with the test 3 review, starting with number 18, a hypothesis test. So when you're doing a hypothesis test, it's good to have all these variables set out. Mu equals H sub 0, H sub A, null and alternative hypothesis, type of test, alpha equals, Z equals, P equals, decision, interpretation. So it says nationwide, graduates entering the actuarial field earn $40,000. So that seems to be our claim here, or that seems to be our population mean, I should say, mu. College placement officer claims that the actual earnings, this is the claim, are higher than $40,000. Okay, so the null always has equals. The alternative is its complement. Hypothesis never has equals. So the claim is that the mean earnings are higher than, that would be greater than, $40,000. That's what someone is claiming. So that's the alternative because it does not have equals in it. That means the null hypothesis is the complement of that the mean earnings are not greater than 40,000. They're less than or equal to 40,000. Remember, the null always has equals in it. The alternative does not. So the type of test always matches to the alternative hypothesis for rejection of the null, which is what we're trying to minimize. So because the alternative has a greater than, it is a right-tailed test. So now we'll keep reading. It says she surveys 36 graduates, so that's our sample size N, and entering the actuarial field and finds the average salary to be $41,000, so that's the sample mean X bar, with a standard deviation S, but we can use that for sigma because our sample size is 30 or greater, of $3,000. Can her claim be supported at alpha equals 0.05? So there's alpha, that's given. That's our level of significance. That's a maximum allowable probability of making a typo in error, which is rejecting a null that's true, that we're willing to make 5%. Okay. So now we are going to calculate a z-score. So to do that, let's first draw our picture here. In the middle goes our population mean of 40,000. Do that again. Okay. And so we are going to calculate a z-score using the longer z formula because we're converting x bar 41,000 into a z-score. So x bar 41,000 minus mu 40,000, which is what we compared it to in the two hypotheses. So that's why we're using that for mu. Over the standard deviation, 3,000 over the square root of the sample size, 36. So subtract first, you're going to get 1,000 over 3,000 over the square root of 36 is 6. So we can do that. Remember, next you would be using parentheses, but then again, we can divide that evenly, so make it easier on yourself and take 1,000 divided by 3,000 divided by 6 is 500. So that's going to give you 2.00 for your z-score. So I'm going to go over here and put this here so that I can find that information when I need it here. Okay, so now what I'm going to do is I'm going to find my p-value, and the way I do that is by drawing and shading a right-tailed test because that's going to be our region here. So I'm going to take that I'm going to take that z-score of 2.00, and it's a right-tailed test. I'm going to shade the right tail, and so my right tail in a right-tailed test is my p-value. Probability of finding a result more extreme than the one we got, and that's probably even farther away than where I drew that. So I'm going to look up 2.00 on the positive z side of the table. Remember, when I look up 2.00, I get the area where? To the left of 0.9772, because that's how our table works. So in order to find my p-value, I'm going to have to take the idea that the total area under the curve is 1 and subtract 0.9772 to get my p-value, which was 0.0228 for our p-value. So now for my decision here, what I do is I compare p to alpha using the decision rule in that order. So p was 0.0228, I just found from my right tail test. Alpha was given at 0.05. So it's helpful to add the same number of decimal places. So I'm going to put a 0 in front of P, 2 zeros on the end of alpha. Going left to right, the ones place is the same, the tenths is the same, the hundreds is different. Is P less than alpha? Is P equal to alpha? Is P greater than alpha? Well, 2 hundredths is less than 5 hundredths. Or 228 10,000ths is less than 500 10,000ths. So when P is less than alpha, as I explained in number 17, that means we can, as our decision, reject the null hypothesis. We're trying to minimize a type 1 error, rejecting a null hypothesis that is true. The probability of making a type 1 error we're willing to tolerate is 5%. It looks like it's not likely we're doing that because we got this p-value that's showing really that our probability is less than 5%, so we can go ahead and reject the null. We're probably not rejecting a null that's true, at least not. The probability is less than what we're willing to tolerate. So the last question is, what does that mean in terms of the claim? And you want to answer the question, can the claim be supported? So if the claim is the alternative, you talk about support. So what are we doing? We're rejecting the null. That means the evidence favors the alternative, which is the claim. So can the claim be supported? Yes. There is enough evidence, because remember we rejected the null in our decision, to support the claim. If the claim is a null, you talk about rejection, like we did in number 17. If the claim is alternative, you talk about support, but then the problem actually asked you about that anyway. All right, so going to number 19, again a hypothesis test. So I'm going to write out all of these variables, mu equals h sub 0, h sub a, type of test, alpha equals, z equals, p equals, decision, interpretation. Helpful to write all that out. Okay, so reading number 19, it says, the CEO of a large accounting firm claims, so here's the claim right here, that the mean workday of the firm's accounts is less than 8.5 hours. Okay, so less than is the alternative. It doesn't have equals in it, so the mean is less than 8.5. That's the claim by the CEO. And since it doesn't have equals, it's the alternative. That means the mu, the complement, sorry, not the mu, the null is what I meant to say. The complement is that the mean is not less than 8.5. It's greater than or equal to 8.5 because the null always has equals. So what we're going to use for mu is what we're comparing it to in the hypotheses, 8.5. The type of test always matches to the alternative hypothesis for rejection of the null. Since it's less than, it makes it a left-tailed test. So we'll draw and shade the left tail. So reading through here, it says, a random sample of 35 of the accountants, that's our sample size, 35, finds that they had a mean workday of 8.2 hours. So that's our sample mean, x bar, 8.2 hours, with a standard deviation s, but we can use that for sigma because we had a large sample of 30 or greater, of 0.5 hours. At alpha equals 0.01 level of significance, can the claim be supported? Again, they talked about support because the claim is the alternative hypothesis. It's going to talk about support in the interpretation. So we're going to calculate z. Let's start by drawing the picture. So in the middle is the population mean mu of 8.5. Okay, we're going to draw and shade a left-tailed test in a minute, but let's calculate our z-score, longer z. So mu x bar, sample mean 8.2, minus mu 8.5 over sigma, standard deviation 0.5, over the square root of the sample size, 35. So this is negative 0.3 over 0.5 over the square root of 35. Using parentheses, again, if you have trouble doing that in your calculator, then take the square root of 35 in your calculator, which is about 5.9161 approximately. Write that down, but then you have to use parentheses to get that calculation right. So if we take negative 0.3 divided by left parentheses 0.5 divided by the square root of 35, right parentheses, equals, I get a z-score of, it looks like it's about negative 3.549. So that's talking, we're saying it's about negative 3.55 for my z-score. So I'm going to put that over here. So to get my p-value, I'm going to draw and shade a left-tailed test using that z-score of negative 3.55, which is way over here. It's a left-tailed test. I'm going to shade the left tail. That's going to a really small amount of area. That's going to be my p-value. So again, I'm going to go to the negative z side of the table and look up a z-score of negative 3.55. So I can't look up negative 3.55, kind of like what we did in number 17. The smallest z I can look up is negative 3.49, which is going to give you an area of 0.0002. So maybe it's even smaller. Maybe it's 0.0001. So that's why I said in the answer that the p-value is 0.0002 or smaller, because I couldn't look up negative 3.55. I'll put it here. Again, when I look up a negative z-score and I want a left-tail test, what I look up is my answer, or it'll be even smaller. But it'll be okay, because that'll work for the decision rule. So we're going to compare p to alpha in that order for our decision rule. So we're going to take our p-value, 0.0002 or 0.0001, it'll be fine either way, and compare it to alpha, 0.01. So again, adding a 0 in front of p and 2 zeros on the end of alpha, going left to right. The ones place is the same, the tens place is the same, the hundreds place is different. Is p less than alpha equal to alpha or greater than alpha? Well, 0 hundredths is less than 100. So p is less than alpha. So when p is less than alpha, our probability of making a type 1 error, rejecting and all that's true, is less than we're willing to tolerate here of 1%. So we're probably not rejecting a null that's true, so we can go ahead and make the decision to reject h sub 0, reject the null. The decision is always, what are you doing with the null? So now in terms of the interpretation, what does that mean in terms of the claim? Can the claim be supported? We are rejecting the null. The null, we're rejecting the null, so that means the evidence favors the alternative hypothesis, which is the claim. It doesn't prove it, but it favors it. So is there enough evidence to support the claim? Yeah. So there is enough evidence to support the claim that the CEO said, that the people at his company work less than 8.5 hours on average per day. Because again, we are rejecting the null, so the evidence favors the alternative. Is there enough evidence to support that alternative, that claim? Yes, because we're rejecting the null. So I'll stop here and I'll pick up on my last video with number 20.